AI, it kind of feels like magic, right? But behind every amazing thing it does, there's this hidden cost, and it's getting bigger and bigger every day. A massive, and I mean massive, demand for energy. So let's dive into this explosive growth and the incredible clean energy race it's kicked off.
Okay, so just to give you a sense of the scale here, get this. According to research from Goldman Sachs, the power demand from data centers, it's projected to jump by a mind-blowing 160% by 2030. And the main reason for that incredible surge? You guessed it, AI.
And here's something else to wrap your head around. Not all computing tasks are created equal. Not even close. A single query on an AI model, say ChatGPT, can use nearly 10 times the electricity of a simple Google search. Now think about that. Multiply that difference by millions and millions of users every single day. Yeah, the scale of the problem gets real fast.
And this crazy energy demand, it goes right down to the bones, to the hardware itself. The specialized GPU clusters that are the workhorses of AI, well, they are incredibly power-hungry. A single server rack built for AI can guzzle up to 150 kilowatts. Now compare that to a traditional server rack, which is maybe sitting around 15 to 20. It's just a whole different league of energy intensity.
So, we've got this massive new demand for power, and that creates a really big problem. Why? Because our existing electrical grid, it just wasn't built for anything like this.
And that's really the core of the issue, isn't it? Our grid, for the most part, is old. It's slow to upgrade, and it was designed for predictable, steady demand. But AI needs huge amounts of power, consistently, around the clock. It's a fundamental clash that our current system just can't handle.
And look, this isn't some far-off theoretical problem. It's happening right now. In major tech hubs like Northern Virginia, Silicon Valley, even Dublin, the grid is already hitting its limits. We're talking about companies facing years-long waits just to get new power connections. Sometimes utilities have to rebuild entire transmission lines from scratch. The growth of AI is literally being choked off by the power grid.
But you know what they say about necessity being the mother of invention? This crisis is actually forcing a solution. Faced with a grid that just can't keep up, the biggest names in tech are making a huge pivot to clean energy. And they're not just doing it for the environment, they're doing it out of pure business necessity.
And this really gets to the new reality of the situation. Renewable energy, it's not just some nice-to-have corporate goal anymore. Nope, it's now the core strategy for building the future of AI. For these companies, this is all about securing a power source that's reliable, scalable, and, crucially, independent.
And it's the industry giants who are really leading the charge here. You've got Google, who's pioneering this power-first idea, literally building their data centers right next to new clean energy plants. Then there's Microsoft, making these massive commitments to buy up renewable power. And Amazon? They become one of the biggest corporate buyers of clean energy on the entire planet. So, the big question is, how is this even possible, right? How can you power something that needs to be on 24/7 with energy sources that are, well, intermittent, like solar and wind? The answer is pretty cool, actually. It's all about a new toolkit of technologies that all work together.
So this new toolkit has a few key pieces that work in harmony. You start with hybrid systems that combine solar and wind to get a more steady, consistent power profile. Then, you add in large-scale battery storage. This is the bridge, basically. It stores up all that excess energy for when the sun goes down or the wind stops blowing. And finally, you have microgrids, which create these self-sufficient little islands of power that guarantee reliability no matter what.
So here's how it works in practice. First, you're generating power from multiple renewable sources at once. Any extra energy that's not being used gets stored in these massive battery systems. Then, you have smart software that's managing everything in real time, deciding whether to pull from the solar panels, the wind turbines, or the batteries. And the end result? A constant, totally reliable flow of clean power to feed those hungry AI systems.
Now, a really crucial piece of this whole puzzle is the microgrid. The easiest way to think about it is like a data center's own personal power plant. It's got its own generation, its own storage, and it can completely disconnect, they call it islanding, from the main grid if there's ever an outage. For something as mission-critical as AI, that level of resilience is an absolute game changer.
Oh, and get this, there's another huge benefit. The advanced cooling and energy management systems that are built into these microgrids are so darn efficient that they can actually cut a facility's total energy use by 20 to 30%. That's a massive saving compared to the old way of doing things.
Okay, so when you pull all of this together, you can really start to see a clear blueprint emerge for how we're going to power the future of AI in a sustainable way. And it really boils down to 5 essential strategies.
First, instead of just building a data center, you build what are called energy campuses, where the data center and the power plant are right next to each other. Second, you have to use hybrid systems, combining things like solar and wind. Third, you absolutely need large-scale battery storage to keep the lights on 24/7. Fourth, you got to be smart about where you build. Go where the clean energy is already abundant. And finally, you use microgrids to make sure you are always on.
When it comes right down to it, the winners in this AI race, they won't be the ones who just see energy as another problem to manage. The real winners will be the ones who see clean, reliable power as a fundamental competitive advantage, and they'll build their entire strategy around it from the very first day.
And that kind of leaves us with one last big question to chew on. We started this whole thing by looking at energy as AI's biggest bottleneck, right? But what if this massive challenge is actually the catalyst we needed? The thing that forces us to finally build a smarter, cleaner, more resilient energy grid for everyone? What if solving for AI's incredible power needs is the very thing that accelerates the entire clean energy transition for all of us?